So Thrust gives a host-side interface that can replace writing CUDA kernels in many cases. But for those times when you are writing CUDA kernels, you'd still like to achieve software reuse. You'd like to identify the building blocks in your kernel and use somebody else's highly optimized implementation of those building blocks and then stitch them together with any custom code of your own. But software reuse in CUDA kernel code faces some kind of special challenges. So suppose, for example, that you were calling a library implementation of, say, radix sort. And this is somebody else's implementation. You're going to call it from inside your kernel. And so the question is, how does that implementation know how many threads it is running in? How much shared memory is it allowed to use? Can it use all of the shared memory, or have you reserved some for other purposes? Should it use a work-efficient or a step-efficient algorithm for this piece of the problem? The answer probably depends on what you're sorting, how much you're sorting, and exactly what's important to you right now. The CUB library by Dwayne Merrill provides a neat solution to these challenges of software reuse for CUDA kernel code at high performance. CUB stands for CUDA Unbound. And the reason it's called that is because the implementation in CUB leave these decisions, like the number of threads, the amount of shared memory, unbound. You, the programmer, bind the necessary parameters when you write your program, using templates and a novel binding approach that's embedded in the C++ type system. The building blocks that CUB provides are really high-performance implementations. So by stitching them together, you can create a high-performance CUDA kernel. And finally, because CUB doesn't dictate things like thread block size or shared memory usage, it allows you to experiment with these values as you optimize or auto-tune your code. And one thing you'll find if you get into optimizing CUDA code is that this kind of auto-tuning, where you experiment with or even automatically sweep the parameters of your code, things like the block size and the shared memory size, that's a really powerful tool for extracting the maximum amount of performance from your code without investing a whole lot of personal effort.